So, good morning, children.
Good morning,
Good
sir.
morning, sir.
So, my voice is audible to you?
Yes, sir.
See, nowadays,
Yes.
the last week onwards, all my classes are going on live in YouTube also. So, if at all, if anyone is facing any problem in accessing the class, you can switch over to YouTube. So, it will take only very minimum data. Don't miss any class. So, I expect all my children to be there in my class. So, live, same thing, whatever we are doing, the same thing is coming live in YouTube. Okay, so you can try that also. Of course, live class means attending the class is far better than watching YouTube. It is different. But if at all by chance, if any child is facing any problem, you can see the YouTube live also. All right, and you can talk to me freely. Whatever problems are there, you can talk to me. You can send messages. Just now I heard that no, some students didn't get the physics mark, that is PWT 1 mark. Some students didn't get. Just a few seconds back, one student sent a WhatsApp message to me. That's why I again send the mark list in all class list. Okay, now, so feel free to talk. My voice is audible now.
Yes, sir. Yes, sir.
Can you see me in that small box?
Yes, sir.
Okay,
Yes, sir.
fine.
Yes,
So,
sir. Yes, sir.
in the previous classes, we were discussing about the different types of forces, means balanced and unbalanced forces. Okay, balanced and unbalanced forces. Then, one second.
എവിടെ പോവാനാടേ എവിടെ പോവാനാടി അബിയെ
Somebody's mic is on. Please switch it off.
എവിടെ പോവാനാടി
Somebody's mic is on. Please switch it off.
എവിടെ വില്ലുന്നി പോണോ
മേടിച്ചു വെച്ചിട്ടുണ്ട് അവിടെ.
അവിടെ വില്ലുന്നിലോ എന്നാ രാത്രി കൊണ്ടുവന്നാക്കൂടെ
ചീത്തയായി പോകത്തില്ല.
Somebody's mic is on. Please switch it off.
ഈ മോദി
നീ മേടിക്കാൻ പോവാ
Please,
TV വെച്ച് നോക്കണം നിനക്ക് TV
who is that?
കാണാൻ
Please switch off the mic. Arun Mani. Arun Mani, you please switch off the mic.
Here's what I found.
Okay, so we shall start. So in the previous class we were discussing about the laws of motion, different types of laws of motion. So all these things we have seen, and before starting the class, now next is we have to solve a few problems from that chapter. And before starting that, let me show you a small video.
My name is Bruce Yaney, and today I'd like to take a quick look at Newton's third law. Newton's third law tells us that if we apply a force in one direction, there's an equal force applied in the opposite direction by the object that we're pushing against. So it shouldn't be too hard to understand. If I have a scale, for me to use the scale properly, I apply a force on one side. There has to be something that I'm pushing against on the opposite side. For example, if I put this down on the table, I push down on the scale. The table underneath it is actually pushing up against the bottom of the scale, and that's why I'm able to get a reading. If I push down harder, the table resists that and it pushes up harder. And so I still have an equal amount of force going down and an equal amount of force going up. Whatever force I apply against the object is then pushed back with the same amount in the opposite direction. Whether I use this type of scale, which is compressing, or whether I use a spring scale where I'm actually stretching a spring, it doesn't matter. If I hold one end, I can't get a reading unless I apply a force in the opposite direction. So if I pull on this side, pull up, I have to pull down on this side for me to be able to get a force. So that's Newton's third law. For every force, there's an equal amount of force applied in the opposite direction. Newton's third law also talks about action-reaction. Now, sometimes Newton's third law can be obvious. The action and reaction of this balloon is fairly simple. I filled it with air, and if I were to release it, the air is going out in one direction, and the balloon goes in the opposite direction. Action and reaction. Sometimes the reaction's not so evident. For example, if I put a line in the floor here, and I want to jump, I actually had to push back against the earth. I'm trying to push the earth backwards for me to go forward. Now, even though I explain this to my students, sometimes they still don't quite believe that that's the case. So here's one more example that we can try, is if I take a skateboard and I put it on the floor. Now, if I try that same jump again, this time the results will be, you would expect to be quite different. I try and jump forward. And I can't, because I'm not able to apply enough force backwards. I've had kids try this year after year after year, and I simply can't get over this line. They say jump up and then go forward. Well, you can't do that. You can't go forward unless you can apply that force backwards. There's a lot of examples that we can use for Newton's third law. One of my favorites is simply to use a car, like this, a little motorized car, and turn it on. The car goes forward because the tires are applying a force backward. He talks about action and reaction. Well, we can see the car going forward, but what we don't see is that it's actually trying to push the desk backwards. So a simple way to see that is to take some pencils, spread them out on the table a little bit, and if you take a piece of cardboard and put it on top of that, it moves very nicely, very easily. And so now if I put the car on top of this, I would then ask my students, what's going to happen? And some of them will tell me the car will go forward, some people will tell me the cardboard would go backward, and some people will tell me the car will go forward, the cardboard would go backward. So we're going to see some of both. So I guess the easiest thing to do is turn it on. That is Newton's third law. For an object to go forward, there has to be something that's being pushed backwards. I can just hold on to it, see the same thing. In this case, it's pushing the cardboard back, and I'm massive enough to keep the car from going forward. So anyway, there's my first example of Newton's third law. Stay tuned because I will be showing some other ones in some later series.
Okay, so let's continue our discussion. We were discussing about the laws of motion, and we have seen the conservation of momentum. Am I audible to you?
Yes, sir.
Only the attendance is less, only 55 to 60 people are coming, and we are taking this much of pain to reach all of them. It's very difficult. Okay, anyway, let's continue. And in the last class, we were discussing about the recoil of a gun. Okay, now this you remember, I think, recoil of a gun we were discussing. Okay, when we are firing a bullet, a gun will be going in backward direction, whereas a bullet will be going in the forward direction. So the total momentum of gun as well as bullet before firing will be equal to the total momentum of gun and bullet after firing, that we were discussing in the last class. Okay, now let's see rocket propulsion, and we have discussed a few demonstrations regarding the rocket propulsion. Thrust is on the ground, and the reaction is on the body of the rocket. So the rocket will go up, whereas the fumes are exerting a huge thrust on the ground. So that we were discussing in the last class. Now we have to solve a few problems. Okay, a few problems we have to solve, and let us start that. Numerical problems. Okay, we have to solve few numerical problems. Let us start that. See here, a truck starts from rest and rolls down a hill with a constant acceleration. Rolls down a hill with a constant acceleration. It travels a distance of 400 meters in 20 seconds. Okay, na? So distance traveled S is equal to 400 meters and time taken is 20 seconds. Find the acceleration. You have to find the acceleration and the force acting on it. How much is the force? Okay, and one hint is given there. The hint is like this: 1 ton equals 1000 kilogram. Okay, you have to find the force. What is the equation for force? F, force F equals
MA.
Yeah, mass multiplied by acceleration. What is the mass here? Mass equals 7 tons. That is 7,000 kilograms. Okay, please give the answers. Don't be silent. Don't be silent. Please give the answers. So 7,000 kilograms. So we can say that F equals 7,000 multiplied by acceleration. And how do you find the acceleration here? We have only distance and time. Okay, now so we have to find out the
Initial
acceleration. So we have three equations of motion. First one is v equals u plus at. Second one is v square minus u square equals 2as, and third one is s equals ut plus half a t square. So which equation we will use here? Out of these three, which equation we will use? We have to find out acceleration. We have s and t. And one more data we have: starts from rest. From this, what we can assess? Starts from rest. It is saying that starting from rest. What we can assess?
Initial velocity.
Yeah, excellent. Its initial velocity is 0. Yeah, its initial velocity is 0. So we have u, s and t. Which equation we will use out of these?
S is equal to UT
Yeah, s equals ut plus half a t square. That is 400 equals ut. That is 0 into t plus half into a multiplied by t square. T square is how much? 20. 20 is t. So what will be t square? How much it will be t square?
400.
This will be 400. Okay, now so 2 multiplied by 400 equals a multiplied by 400. So what will be the value of a? Come on, what will be the value of a?
2.
Yeah, 2. Adu parayu. 2 meter per second square. Be smart.
2.
Yeah, 2 meter per second. Quick answers vanam. Be smart, dynamic. Okay. Now 7,000 multiplied by acceleration. So 7,000 multiplied by 2, which is equal to 14,000 Newton. Okay, now see how simple it is. This is a textbook question only, exercise question. Okay, now so you have to depend on the three equations of motion. Three equations of motion: v equals u plus at, s equals ut plus half at square, and v square minus u square equals 2as. Okay, is it okay?
Yes, sir.
Okay, sir.
Any doubts?
No, sir. No, sir.
Anybody is having any doubt, you can ask now. You can raise now. Okay, now let's see the next question. A stone of 1 kilogram is thrown with a velocity of 20 meter per second across a frozen surface of a lake and comes to rest after traveling a distance of 50 meters. So what is its initial velocity u?
0.
Yeah, 20 meter per second. Somebody was sleeping. 0 nu parnju aro. It is 20 meter per second initial velocity. What is its final velocity? V. Yeah, it is 0. It is 0.
0.
What is the distance traveled by that one? Distance travel.
50 meters.
Yeah, it is 50 meters. 50 meters. Now, what we have to find out? What?
Force.
Force of
Force.
friction. Force we have to find out. Force. Force is equal to mass into acceleration. Okay, now? Mass is also given there. How much is mass?
1
1
kilogram.
1 kilogram. It is given there 1 kilogram. Mass is given there 1 kilogram. Initial velocity. Okay, distance, all these things are given. So, which equation we will use there? As in the previous case, we have three equations. V equals U plus AT, S equals UT plus half AT square, and V square minus U square equals 2AS. Out of these three, which one we will use? We want acceleration. Which one we will use?
square minus
Yeah,
U
V
square is
square
equal to
minus U
2AS.
square equals 2AS. What is V? 0 minus 20 square. How much is 20 square?
400.
20 square is 400 equals 2 multiplied by A multiplied by 50. What will be the value of A? Calculate and tell me. What will be the value of A? Calculate and tell me the value of A.
Minus
4.
minus 4.
Minus
4.
minus
4 meter per second square.
how much? Minus
Minus 4 meter per second.
4 meter per second
Minus
square. Yeah, right. So it is 1 multiplied by minus 4 meter per second square. So this will be minus 4 Newton. Okay, na? So what is the meaning of this minus? A minus meaning endarikkum. What will be the meaning of minus 4? Negative 4. Force is negative. What does it mean? Come on, force is negative. Force is negative. What does it mean?
Sir, a negative acceleration.
Yeah, it is having a negative acceleration. It would mean that
Sir, retardation.
force is acted. Yeah, retardation. Force is acted against motion. Force is acted against the motion. That is why the negative sign. Force is acted against the motion. Okay, see this one. Any doubt you tell me? Any doubt you tell me? Any doubt regarding this one? No doubt? Doubt is there or not?
No, sir.
Okay, is it okay? Shall we move to the next?
Yes, sir.
Okay, fine. Now this you have to tell me how to solve. An automobile vehicle has a mass of 1500 kilogram. What must be the force between the vehicle and road if the vehicle is to be stopped with a negative acceleration of 1.7 meter per second square? This you have to tell me how to solve.
F is equal to ma is equal to
No, you tell me your
Physical
name and
mass and
answer.
answer.
First, you tell me your name. I will write your name and your answer I will write here. And finally, we will check it. It's a game. Your name you tell me, your answer you tell me, your name and answer I will write, and finally we will check which one is correct. Come on. No one is there enough. Okay, no need of name. Just tell me. I won't write your name. Okay.
Force into force is equal to ma mass into acceleration.
No, final answer.
15.5.
The first answer came, it is 15.5 Newton. Okay, na? Any other answer? No other answer. Hey, what is this? This is very bad. It's a very simple question. Okay, tell me how to solve this.
One 1,550.
Yeah, that is the mass. Mass is equal to 1550. 1500 kilogram. And what is the acceleration here? It is 1.7.
Minus 1.7 meters.
Stopped. Yeah, very good, very good, very good. It is negative acceleration, so it is minus 1.7 meter per second.
Minus
So equation for force is equal to mass multiplied by acceleration.
MA.
That is 1500 multiplied by 1.7 with a negative sign. Then what will be the value of 1500 multiplied by 1.7?
255. 255.
255. No, it's not 255.
2,550.
2000.
2,550. 2,550
Newton. 2550 Newton is the correct answer. Okay, na? So just a little bit of numerical skills you have to improve. Okay, multiplication and all these things you have to improve. So basic equations you have to remember. Only basic equations. We are not doing any miracles. We are not doing any circus or anything like that. So these are all very simple things, very fundamental things. Shall we do another one?
Yes, sir.
Ready? ഇങ്ങനെ പറ്റില്ല, നിങ്ങളുടെ പാർട്ടിസിപ്പേഷൻ ഇല്ലാതെ നടക്കത്തില്ല. ഞാൻ ഇങ്ങനെ പാസീവായിട്ട് പറഞ്ഞുകൊണ്ടിരിക്കും, ചുമ്മാ സിനിമ കാണുന്നതാണ്, അത് ശരിയാവത്തില്ല. If you are ready to participate, we will move on to the next one. Otherwise, we will stop.
The next was
Ready, sir.
Ready. Okay, fine.
Ready, sir.
Fine. So now you have to tell me the answer. I will write answers 1, 2, 3 like that, and then I will solve it. I am not going to solve further questions. Okay. See this one.
okay.
See this one. It's for you. See, a horizontal force of 200 Newton, we intend to move a wooden cabinet across a floor at constant velocity. What is the frictional force that will be exerted on the cabinet? That means we have a floor, we have a cabinet, we want to move the cabinet, we will push, we will apply some force, we will move the cabinet. When we are moving the cabinet, how much will be the frictional force? So if we apply 200 Newton here, the same 200 Newton will be applied by the ground over this. That's why it is not moving. That's why there is no net force. Okay, see this constant velocity, there is no velocity change, constant velocity. See, if velocity is constant, what is the value of acceleration?
0.
Yeah, that is 0. If
Zero.
acceleration is 0, what is the net unbalanced force? Net unbalanced force.
0.
Yeah, that also will be 0.
Zero.
Net unbalanced force will be 0.
0.
That means
Zero.
we are applying 200 Newton like this. Floor is also applying 200 Newton in the opposite direction. We are applying 200 Newton towards right. Floor is applying 200 Newton towards left. So the net unbalanced force becomes 0. Okay, so that is the case of friction. If it is moving with a uniform velocity, that means constant velocity, no change in velocity means no acceleration, no force. Shall we move?
Yes, sir.
Yes, sir.
Yes, sir.
ആർക്കും ഒരു ഇതില്ലല്ലോ,
Sure.
നിങ്ങളുടെ ആ ഒരു എനർജി ഒക്കെ പോയി. ഇനിയിപ്പോൾ തിരിച്ചു വരുമ്പോഴത്തേക്ക് ഏത്
Yes, sir.
അങ്ങനെ ഇതിലേക്ക് വളരെ പാസിഫൈഡ് ഇതിനകത്ത് വരും, ഒരു ആക്റ്റീവ്നെസ്സും ഇല്ലാണ്ട്. പിള്ളേർ ഇങ്ങനെയാണോ വേണ്ടത്? പിള്ളേർ ഡൈനമിക് ആയിരിക്കണ്ടേ. Now see this one. Two objects each of mass 1.5 kilogram are moving in the same straight line but in opposite direction. Velocity of each object is 2.5 meter per second before the collision, during which they stick together. ഇതിവിടെ ഇല്ലേ, stick together. See this question. Two objects of mass 1.5 kilogram. This is 1.5. This is another 1.5. Moving in the straight line but in opposite direction. The velocity of each object is 2.5 meter per second. This is 2.5 meter per second. During the collision, they stick together. What will be the velocity of the combined object after collision? ഇത് നിങ്ങൾക്കിത് yeah, it will be 0 because no total
Zero.
momentum, let us work it out. Total momentum before collision എത്രയായിരിക്കും? 1.5 into 2.5 plus 1.5 into minus 2.5. Why that minus 2.5? Yeah, opposite direction, minus 2.5, so it is 0. So total momentum before collision is 0. Then what will be the total momentum after collision?
0.
Total momentum after
Zero.
collision also will be 0. So total momentum before collision is 0. So after collision they stick together and as a single unit it is moving. Its momentum will be 0. So it will come to rest. It will come to rest. It is something like two equal objects. So two equal forces balance each other after the collision. Clear?
Yes, sir.
Yes, sir.
Okay. ഇത് നിങ്ങൾ എന്തായാലും ചെയ്തേ പറ്റൂ. So I'll give the input. A bullet, mass 10 gram. So mass of bullet equals 10 into 10 power minus 3. Coming like this, it is hitting a wooden block. Its velocity was 150 meter per second. 150 meter per second and comes to rest. So it is getting embedded to it. Okay, na? It is bullet travels certain distance and comes to rest. Okay, so the time taken for the bullet to come to rest is 0.03. 0.03. Now the distance of penetration of the bullet into the block. Adana calculate cheyanda. So this is the distance of penetration of the bullet into the block. So when it touches the wooden block, what was its velocity? That is u. What was the velocity when it touches the wooden block?
150 meter.
150 meter per second. And after traveling for a time interval of 0.03, what will be the final velocity of the bullet?
0.
Yeah, 0. What is the time taken by the bullet to travel that much distance? It is 0.03. What we have to find out? We have to find out yes. Okay, na? Yes. All right.
Yes, sir.
Okay. Now for that you need acceleration, or that this acceleration in this time interval. Acceleration, we know what is acceleration.
V minus
E
U.
minus
Yeah,
U
v
by
minus
T.
u by t. V minus u by t. Now you tell me the answer for the first part. That is this part. This is the first part. Tell me the answer for the first part.
V minus U by T.
Yeah, the final answer. Final answer. Distance. Calculate the distance and tell me. Come on, quick.
2.25 meter.
2 point. Please repeat.
2.25
2.25 meters. Any other answer? Okay, let us sort it out. Acceleration equals v minus u by t. That is 0 minus 150 divided by 0.03. That is 150 0 divided by 3. How much it will be? Negative 500. So yes, we can use this equation. V square minus u square equals 2as. S equals v square minus u square by 2a.
5,000 late.
How much?
5,000 late. 5,000 late.
Yeah, 5,000. Sorry. Okay, 5,000.
Sir, 5,000.
Ade 5,000 aanu. Right. So v square minus u square. V square is how much? V square is 150 square. 150 multiplied by 150 minus 0 divided by 2 into 5,000. How much we get? This will be equal to that is S equals 15 into 15 divided by 10.
225.
225 by 10, isn't it?
Yes, sir.
225 by 10 alle.
Yes, sir.
So it will be 22.5.
22.5.
Yeah, 22.5 meters. But I appreciate that student who told 2.25. It was correct, except that decimal value was a little bit disturbed. Okay, now. So next time she will improve. Okay, anyway, I appreciate that. She was the first one and she got the answer within 10 seconds. That's appreciable. Okay, so the answer is 2.25. Now a second part is also there for this. Calculate the magnitude of the force exerted by the wooden block onto the bullet. Wooden block onto the bullet. There we have the acceleration. Acceleration is there. Okay, now. Then we have to find out the force exerted by bullet on the wooden block. That we can calculate the force. Force exerted by the bullet on the wooden block. Force exerted by wooden block on the bullet will be the same as that of force exerted by bullet on the wooden block. So അപ്പോൾ force എന്ന് പറയുന്നത് we can calculate like this, m into a. Yeah, mass of the bullet is 10 gram, that is 10 into 10 power minus 3 multiplied by acceleration is, how much is acceleration? 5000. So we get 50 Newton. Got it?
Yes, sir.
Sir.
Any doubts?
No, sir.
No, sir.
Any doubts? Let me check how many are there. Only 48, very less. People are not at all coming. Okay, shall we have you copied it? നിങ്ങൾക്ക് ഇവിടുത്തെ മഴയുടെ ഒച്ച കേൾക്കുന്നുണ്ടോ?
കേൾക്കാം സാർ.
ഓ പടപടാന്ന് മഴ പെയ്യ. Over. എഴുതി കഴിയുമ്പോൾ പറയണേ. എല്ലാരും പോയോ? Are you there or not?
Yes, sir. We are here.
കഴിഞ്ഞില്ലേ? എന്താ എല്ലാരും മഴയുടെ ഒച്ച കേൾക്കുകയാണല്ലേ? സുഖമായിട്ടിരുന്ന് കഴിഞ്ഞില്ല? Any doubts regarding this?
No, sir.
No, sir.
Shall we see the next?
Yes, sir.
Yes, sir.
Yes, sir. Sir.
Okay, let's see. This you have to tell me the answer. This is for you, you have to tell me the answer.
Sir, question കാണത്തില്ല മറ്റേ പഴയ ക്വസ്റ്റ്യൻ ആണെന്ന് ബുള്ളറ്റിന്റെ.
Bulletindeyo? Now it will come, it will come. You are watching in YouTube or Teams?
Sir, Teams.
Takes lag ആവുന്നോ?
Sir, ഇപ്പൊ കാണാം, ഇപ്പൊ വന്നു.
Okay, there may be a lag. Okay.
Sir.
Yeah.
Sir, force 50 Newton.
Force is 50, 50.
50 Newton.
50.
50 Newton.
Yeah, 50.
Yes, sir. 50.
Yes, sir.
Initial and final momentum. Let's see initial momentum. Equals mu, that is 100 multiplied by 5, that is 500 kilogram meter per second. Final momentum, that is mv, 100 multiplied by 8, that is 800 kilogram meter per second. Okay, now change in momentum. Change in momentum, how much it is? That is 800 minus 500, which is equal
300
to
kilogram
300
meter per second.
kilogram meter per
300
second.
kilogram.
Very good, very good. Now rate of change of momentum. It is equal to 300 divided by time.
300 by 6.
That is 300
300 by 6.
equals
6.
6 of
50 Newton.
yeah 50. It is
50. 50.
So this will be the force.
Yes.
Okay, now force is 50 Newton. Very good, very good. and at the
Force is 50 Newton.
yeah, I'm very happy that the last question all of you made it correct. Very good, very good. Keep it up. Okay, so that's enough for today. So we have covered almost everything in this chapter. What you have to do there is, all of you may be having textbook. Okay, now if anyone is not having textbook, you tell me, I'll send it the PDF format. And you have to solve all the exercise questions. And if at all any doubts, you can call me, you can WhatsApp me at any time, no problem. And even if anything is left in this chapter without clarity or anything, you can WhatsApp me. I'll make it once again. Okay, right. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
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 അവിടെ വായിച്ചാൽ മാത്രം മതി.